So let's look at this, and we're gonna look at this. Obviously, if this were on the test, first of all, if this were on the test, I should have my head examined, because this question here is, how shall I say, not intermediate algebra material. Okay, because if you add straight down, you get 2x equals 6. Divide by 2, divide by 2, x is equal to 3. And some of you are going, thank you. Perfect test question. Can we see a sister? Something close? If x is 3, y is what? 3 plus 1 equals 4, so y is 1. Okay? Now, but here's what I want to do. I want to look at this through graphing. Now, this is another case with what you were talking about. If I said solve this by graphing and you do that, well, hell, I hope you'd be able to do that. If I say solve by graphing, though, that's a lot harder. It's a lot harder because, dang it. And it may not work because I changed the way the damn graph looks, but hopefully it's proportioned. If I say solve by graphing, what do you have to do? Well, you have to graph x plus y equals 4. So to graph x plus y equals 4, find the intercepts. X is 4. And to find the y-intercept, y is 4. Right? So then we're going to connect those dots, right? Close enough. Okay?
Make the dot bigger.
And it always goes this way as well. You get the idea. Okay? Now, to graph the next one, to graph x minus y equals negative, or x minus y equals 2, we'll graph that one in red. X minus y equals 2, you graph that by doing the x-intercept and y-intercept. So if you plug in y as 0, you get x equals 2. So that's here. If you plug in x is 0, you get y, negative y equals 2. So y equals negative 2, right? So that's this. Okay. And then you're going to graph these lines, right? And so, and again, this is a line that kind of goes all the way the other way, yes? You get the idea. But now, what's the significance of this intersection point? That's the answer. The significance of the intersection point is the answer. So when I say solve, verify your answer graphically, and I want you to notice what I said, and this will be on YouTube. When, which is entirely different than if, when I say solve by graphing, you have to graph both equations, and where they intersect will be the answer. Okay? Now, here's what I want to do. Let's look at the problem that's in discussion.
Will they all be perpendicular?
That's the question. That's the question. You see, what happens if we have a problem like this? Solve x plus y equals 5. Solve x plus y equals 7. Right? Well, if I have a problem like that, I fall for that every single time. Okay. If I have a problem like this, well, then what happens is the x-intercept is 5, the y-intercept is 5. Hopefully everybody sees that. And so when I draw a line, or I draw 2, okay? When I draw a line, it goes through there. Now 7 and 7, right? What happens?
They have no intersection.
So you get the idea. They're parallel. So what does that mean? There is no place where they intersect. Do we agree?
Yes.
There is no place where they intersect. But now here's the deal. If we solve this by multiplying by -1, -1, so that we could cancel the x's out, what would happen? The x's would cancel. The y's would cancel. Now it starts to look like that 0 thing again, right? And then what happens here? You get -5 plus 7 is, and when you see 0 equals 2, what are you going to know? The answer is no solution. Okay? But now to go to the question at hand. Now to go back to the question at hand. The question at hand was this one.
So if you get like 0 equals something and it's not a true statement,
Then it's no solution. Yes, ma'am. So again, let's go back to the question at hand. Now this was the question at hand, if you remember from earlier. Okay. If I were to graph this, the x-intercept is -2 for this one. Let's look at this one first. The x-intercept is -2. 2x minus 5 times 0 equals -4. X is equal to -2. I hope everybody sees that. X is -2. Now the y-intercept, if you plug in x is 0, and you divide by -5, you divide by -5, you get y is equal to, negative divided by negative is positive 4/5. Do we agree? So positive 4/5, I don't know, it's in here somewhere. Right? And so there's your line. Your line would start here, go through there. Something along that magnitude. Do we agree? Now let's look at the next one. I'm not. Let's look at the next one. If I have to do -4x plus 10y equals 8, let's find the x-intercept. Plug in y as 0. And what's the x-intercept? -4x equals 8. Divide by -4. Divide by -4. X is what? Oh, what the hell? You guys let me jack that all to hell. Son of a... Damn it. Aren't y'all paying attention? Huh? And for those of you watching that was not in class to see it live, let me explain to you quickly what happened. The instructor's an idiot. That's number one. And I plotted -2 over on the right-hand side as opposed to the left-hand side where it should have been. Then when I got down to -2 down here, I realized, oh, gee, I plotted it in the wrong spot. So I hit pause. I yelled at the class for not fixing it. And now we're straight. Okay, so x is -2. We're back to red again. We're good. Now, finding the y-intercept, -4 times 0 plus 10y equals 8. Dividing by 10, dividing by 10, y is equal to 4/5. Ironically enough, that's what we had before. So that point must be right here where this one was originally. So this line then is what?
Scary.
I'm using a dotted line, but watch this. You will not even tell it's dotted. Why is that? Because they are exactly the same line. Now here's the problem. For everybody who just wants to go Jesus on me and say -infinity to infinity, and that's a pretty good answer. Okay? The problem is there are a lot of points that don't satisfy the equation. Like this one don't satisfy both of them. This one doesn't satisfy both. Hell, there are equally as many of them that don't satisfy it that do. So what we have to say is what? Well, it's the solution for this. Where do they intersect?
On the line.
They intersect everywhere on the line itself. So how do I say that?
So you're saying the points
The squiggle.
of the.
I'm saying that they will intersect everywhere that the points are on the line. So I say that with this really funky notation, which is X, Y, any ordered pair on this line.
So it's not some funky absolute value thing.
No.
Just making sure.
Now you'll notice that which equation I choose really doesn't matter, does it? Because both equations are the same anyway. They're both on the same line. So it's any ordered pair on the line that. And that's, people go like this. That one line in the middle means all that? Yes, basically.
I thought it was some funky absolute value thing. I thought that was
Okay.
even more.
All right.